Okay, this is in topic moment, right? So you have learned about moment. So write down two conditions. So the first condition, upwards force must be equal to the downward force. So that is when a resultant force is 0. So you can say no resultant force or no net force. So this is about moment. So what is another condition for it to be in equilibrium? So you must remember this. The second condition is, yes, exactly, clockwise moment equals to anti-clockwise moment, because this system can rotate. So if the clockwise moment is not equal to the anti-clockwise moment, it will rotate. Okay, so if you write these two, you will get this right. So you must remember this. Okay, they are equal. Okay, show that the value of the reading on the spring balance is 8 Newton. So now you have to show. So you just use this statement and then you write it in the form of mathematical formula. So moment equals to F times, F is the force times the perpendicular distance. Okay, so the clockwise equal to the anti-clockwise. Then what should you do? Now the question is, okay, you know the forces. No, okay, you know the force. You want to show it is 8 Newton in the other side. Now you have to figure out the perpendicular distance. So where exactly is the perpendicular distance? So the 6 Newton weight, if we don't have the, let's say we don't have the spring balance, okay, it will rotate anti-clockwise. Now if let's say we don't have the 6 Newton weight, we just have the spring balance, it will move clockwise. Do you understand that? Okay, you can pause again and try to understand that. Now next, so when we know that, so we write down the values in the formula. Okay, so the perpendicular distance of 6 Newton is 40. 1, 2, 3, 4, so 40 centimeters. But for the spring balance, 1, 2, 3, 30 cm. So the distance must be from the pivot. So you see this one, perpendicular. Okay, you must remember it's perpendicular. Okay, then we write 30. No, that's the force side. Okay, so you better follow the formula lah. So F, which we want to know, times 30 cm, and then times the 6 Newton force times 40 cm. So what do you get for the F? So it is proven F equals to 8 Newton. Shown, proven. Okay. Now what's the weight of the uniform meter rule? The weight of the uniform meter rule is 1.5 Newton. Calculate the force exerted by the Okay, for this one, a large plastic ball is dropped from the top of a tall building. So this one is related to gravitational acceleration, free fall. Okay, figure 1.1 shows the speed time graph for the falling ball until it hits the ground. So the one that I highlighted ni, okay, this is the, okay, so that is the value for the terminal velocity, the time during which the ball is travelling. So you must answer in a range 4.2 to 6 seconds. The time during which the ball is accelerating, A2. Okay, which one? Accelerating. So, okay, this part. So, you see the increment of speed. So, starts from 0 until 4.2 seconds. The distance, now A3, the distance fallen while the ball is traveling with terminal velocity. So, in order to find the distance, so for speed time graph, if you want to find the distance, we can use area under the graph, okay, to get the distance from a graph of speed against time graph. Now, the question was distance with terminal velocity. So just now terminal velocity, that's the region. So we want to estimate this area. So the area will be the distance. And this question is just estimation. So that's we can just calculate the boxes, which is 20, or just refer to the graph. If you look at the diagram, 6 minus look at the 4. Time. Okay, so 6 yes, that's 4. The boxes. That gives us 2 seconds. Oh, it's not 4, 4.2. Okay, because we cannot start from 4. So 6 minus 4.2, that is 1.8 times with the height of the rectangular, which is 20. Okay, and then we just use calculator. 1.8 times 20, that gives us value of 36. So our estimation of the distance for the ball traveling with terminal velocity is 36 meters. Now, okay, that is 1.82 t and 22 the speed. You just get the from the graph. And then next question from the graph as well. Okay, so that's the region. Okay, move on to the next question. Again, we are going to estimate the height of the building, and you must use the graph. Okay, if you look at the question, drop the top from the tall building. So we need to calculate all the distance from the beginning, from 0 time until time equals to 6 seconds. So for this, we need to calculate area under the whole graph. Because the ball fall from the tall building. So if you look at the shape of the graph, under the graph, so it's the shape of rectangular that we have just calculated plus some sort of a trapezium. This is estimation, remember? So half V times T. Oh, not trapezium, triangle. Kan? It's like a triangle. Nampak tak? Macam triangle. Okay, estimation only. So the height is V, the base is time. So we just substitute V. Okay, if you look at the purple triangle I've drawn, so the V is 20 for the graph, and the T is 4.2 minus 0, which is 4.2 lah, plus 36. Where do you get 36? From the ones that we calculated just now. Kita dah kira dah 36 tu. So just use calculator and we just add them up. We get 78. This is height, so 78 meters. Don't forget to write meters, the unit. Okay, so that's easy. Okay, we take from that. So make sure you understand, where do I get from the 36 meters from? Okay. Right, hopefully everyone understand this one. You just need to understand what I do. Okay, this is another question of a moment. Okay, very direct question. We have two children. Child A has a mass of 18 kg and child B has a mass of 20 kg. But it says A sits at X and B sits near end Y. Okay. Right, so with that info, without calculation, indicate where the children could sit so that the seesaw balances. What do you think? So first, okay, this is 2 marks. So of course, you know, in order to be balanced, both of them must sit opposite. One slightly nearer to the center and another one slightly further from the center. Next, the 20 kgs to children is the nearer to the pivot, and the other one is further from the pivot. Okay, now so graphically, so this is what you draw. Okay, and then B, state the relationship between moment caused by children A and then caused by children B. What's the relationship? I think by now everyone know to answer this question. Okay, again, clockwise moment equal to, so the relationship is equal. Okay, it's not the more or the higher, no. So for this one, the relationship is clockwise moments equals to anti-clockwise moments. Okay. Now child A is 2.5 meters from the pivot. Calculate the distance of child B from the pivot. So draw this. Child A, then child B, A 18 kg, B 20 kg. So we want to know the distance of child B from the pivot. Given that children A 2.5. So this is easy, you know the relationship, you write down the formula based on the relationship. Okay, again, right, so 2.52, okay, from pivot. So write down the formula. Here, remember, moment equals to F times perpendicular distance and force. What's the force? The weight is the force. Okay, remember, weight is a form of force. So this is the formula of moment equals to moment anti-clockwise equal to moment clockwise, and then 80 kg times with the perpendicular distance 2.5 equals to 20. Okay, for now I just use the mass. Okay, you don't need to find the weight because both of them the kgs too can be cancelled out. Okay, otherwise, okay, the F actually is 180, FB is 200, but you can just use the mass because it can be cancelled out. Okay. Okay, just now along LB, this one. So you see, accelerating. But this one, is it just now? So speed dia tak berubah. Speed uniform. But circular path. So what changes? Direction change kan? Hence we say this part. So the complete answer is, so you must include velocity changes. So speed uniform, but velocity changes. Why? Because velocity has direction. Direction always change. So this is the question. Okay, this is easy. The mass is this one. Acceleration. So what's the weight? Okay, that's true. So that's the weight. Okay, this question. The uniform meter rule shown is included.